Choosing the right bullet for the proper application is paramount to success in that application. In this video, we're going to talk specifically about long-range shooting. Not only long-range target shooting, but we're also going to discuss hunting bullets and also bullets that will work in tactical applications. So we're going to look at these different bullet profiles to get started, and then we're going to show you some of the comparative analysis we've done, plotting the trajectories of different bullets in their class, and discussing which of these bullets will work best for the application you are trying to master. Howdy guys, Rex here. As you can hear, we are in the bathroom of the Pizza Hut again, like we were on a former video. You guys made some funny commentary. We got a little bit of echo. That's to make my voice sound more full and beautiful for you. But we're going to talk about long-range bullet dynamics today. We did cover this in the Sniper 101 series. However, this video is going to be a little different. I'm going to show you general trends again. I'll give you a little review of what we're looking for in general when we talk about long-range shooting as opposed to other applications like varmint shooting or large game shooting. But in this video, I'm going to give you some of my opinions on different makes. As you can see, this is just stuff I grabbed off the shelf in my reloading room. And I use a diversity of different bullets. I try all kinds of stuff. They come in all different kinds of packaging. Sometimes you find them in the gun show in this big jar here. Sometimes, you know, you like the stuff in the red box, the green box, the clear box, the white box. So I'm going to give you my opinion on different long-range bullets, and I'll tell you the advantages, disadvantages, and what I think is maybe the absolute best for certain applications. And we'll talk about hunting, target shooting, tactical, everything like that. So you guys should dig this. So to get the video started, let's talk about just general dynamics of what you're looking for in a long-range bullet. As you can see here, I'm going to adjust this and come down a little bit so we can get the angle more cinematic. More of a 90-degree angle on these bad boys. As you can see here, you have a plethora of different bullet shapes and contours and proportions to choose from. Generally speaking, the longer, sleeker bullets with more of a sleek design, just generally speaking, are going to have a higher ballistic coefficient. That means they're going to have a greater aerodynamic efficiency when they're flying through the air. And that's going to be conducive to long-range hit probability because the wind is going to push you around less if you have a longer, sleeker, and heavier bullet. Also, your velocity will be maintained over longer distances, giving you at long ranges a flatter trajectory than something that you might shoot at shorter ranges at a higher velocity. Case in point would be this little guy. Here we got the 40 grain, 22 caliber varmint style bullet, right? This is just a spire point. This is a Sierra 40 grain soft point. The ballistic coefficient on this bad boy is only going to be just a little bit over 0.1. I think it's like 0.117. Pretty small, little stubby bullet with a square base, not that sharp of a tip. This is designed to be shot at high velocities, so this is going to have a very flat trajectory while the velocity is high, which is only going to be a relatively short distance, maybe a couple hundred yards. After that, the velocity on something like this is going to drop off tremendously. You look at another bullet in the same caliber. Here is a what they call the SS-109 projectile. This is the 62 grain steel core bullet that the military uses for the 5.56 millimeter. Okay, and this is what's loaded in the M855s. This has a sleeker design, longer, a bit heavier. You got a pointy nose. You got a tapered base like a boat. It's called a boat tail. The reason for that is you don't create a drag, a nasty drag behind there. Kind of like if you were pulling a square-ended boat through the water, all that water is trying to, that void behind there is going to kind of create a drag behind the boat, and it's not going to go through. That's why canoes are shaped the way they are, with the pointy end on the front and on the back, okay? So this is going to be way better in terms of aerodynamic efficiency, which is going to be quantified in what they call the ballistic coefficient. I think the BC on these is in the 3s, 0.3 something, okay? As opposed to 0.1 on this bad boy. So you can just tell by basic proportionality. Likewise, when you get into your 6mm bullets here, we got a couple different 243 caliber 6mm bullets, right? This is a little 58 grain V-Max, Hornady V-Max. Good little bullet. Again, this is designed for close range high velocity varmint shooting, but it's gonna drop off its speed tremendously because its BC is only 0.250. So it's basically gonna be real good at close and medium range, and then at long range it's gonna really have a hard time. It's actually gonna be slower than these guys, okay? Look at this guy, and this is like a 90 grain full metal jacket. The BC on that's going to be significantly better. It's going to be in the 400s, I reckon. This is the bullet that I prefer to use in the 6mm. This is my favorite bullet in the 6mm. This is the Hornady A-Max. Now, I will talk about A-Maxes in a little bit and something that Hornady recently discovered concerning polymer tip bullets. But this is the classic A-Max, a very well-designed bullet. I've seen some of the most amazing things ever done when there's no wind with these A-Maxes. The BC on this is 0.500, if I remember correctly. And it'll give you a nice flat trajectory in a 243, similar to that of a 300 Win Mag with 190 grain bullets. In a much lighter package, much cheaper to shoot, much less recoil when we're talking external ballistics. A very good target bullet. You can even hunt with it. It's got enough weight to kind of take out deer. It's not really designed for that application. It's great for varmints and it's great for target shooting. When we get into the 7mm projectiles, let me adjust the camera here. I'm kind of looking around. We have, this is a hunting bullet in a 7mm. You can see this is a 139 grain SST. Now the hunting part of it, you're not going to be able to really tell by looking at the outside. That's all internal construction. So you're going to have a cutaway of what's going on, kind of like they have right about here. See on the box on the SSTs, it kind of shows you how it's built on the inside. So all that stuff is going to determine your terminal ballistics, how the bullet is constructed, the jacket thickness, if the core is designed to kind of hang in there after it strikes the target. So you're not going to be able to tell just by looking at the shape of the bullet, you know, really for determining if it's going to be a good hunting bullet. But you can get a good idea of the aerodynamic efficiency or the ballistic coefficient. And you can see it's going to have a pretty good ballistic coefficient because you have a boat tail, you have a spire point. It's proportioned kind of long and sleek, but it's not going to be like ridiculously efficient. What was the BC on this? I wrote it down on the box, 486.486. So it's not quite as efficient as a 6mm, even though it's considerably heavier. Proportionally, this is sleeker, longer, you know. There's less cross-sectional area here, and this is not quite as sleek and long, right, as compared to this 105 A-Max. So that's kind of the name of the game, proportions, like it was in our cartridge video we did earlier. Now we can look at something, this is kind of a proprietary bullet design. This is kind of new on the market. This is called the Alco. These are really, really good bullets for long range shooting applications if you're trying to push it really far out there. This particular one, I believe, is a 168 grain Alco, and they have an aluminum tip and a rebated butt end on them. See that there? It's kind of an interesting design. And when you talk about these Alco bullets, you can see how pointy that tip is on there. And let's see if I can get the zoom a little better. But because it's aluminum, they're able to machine that in such a way to where it's actually very pointy. And if you get real close on the polymer, you can see it's slightly rounded just because of the properties of plastic. Plus, there's going to be no deformation of the tip whatsoever in flight. A typical rifle bullet, like with a polymer tip, when you shoot it due to aerodynamic drag heating, kind of like when the space shuttle's re-entering the atmosphere, you know, it glows red. That happens on a lesser degree in a rifle bullet. You're going to maybe have 800 degrees of temperature on this bullet, and actually these polymer tips on most of these bullet designs, they deform in flight. They become more plastic. And I mean that in the state-wise, you know, it becomes almost liquid, and sometimes they actually get in liquid state, because these are plastics, a lot of these are only designed for like 400 degrees. So there is some deformation of the tips on polymer designs, so that is a superior part about a metal tip, like aluminum. And so this is the Alco 168 grain RBT aluminum tip. And the ballistic coefficient on this bad boy, just by looking at how long and sleek it is in the 700s. This is a 764 ballistic coefficient on a 175 grain bullet. Very, very efficient design for long range. You might also notice there's a little bit of a bulge in here. See that dark line there? that is a bulge. It's actually skinnier up here. This is a portion that does not come into contact with the bore. This is the part that comes into contact. This is what they call a bore rider design. This is used and commonly employed in long-range black powder cartridges from the old days. I know a lot of guys who shoot the 50 cals, the 5140s, the 4570s, stuff like that, and they mold their own custom bullets. And to reduce friction in the bore on an extremely long bullet design like this, because you're trying to maximize your ballistic coefficient, you need a longer, sleeker bullet. Well, the longer your bearing surface is here that rubs on the rifling, the higher your pressure is. And pressure isn't necessarily your friend. You want to try to limit your pressures, right? So this limits the contact area to here. Plenty enough to stabilize the projectile, but you're not deforming more bullet than you need to with the rifling, and it's not spiking your pressure as much as you would need to. So you come up with a very good design. So it's kind of a unique proprietary bullet design. Likewise, if you look at the butt end here, you see it's kind of got a unique shape. And they found that with this standard boattail design, this is what like a Lapua Skinar bullets kind of have the similar design, rebated boattail kind of deal going on back here, right? On a standard design, when this kind of a bullet with a boattail exits the muzzle, the gases are trying to shoot up. And they actually kind of get in front of the bullet before it completely exits. A supersonic jetting of gas at the muzzle. And we talk about this briefly in our transitional ballistics video, but what you have is a fireball, a gas ball, that gets in front of your projectile right as it exits the muzzle due to supersonic jetting around this boat tail. And this bullet then has to make it through that disturbance in the air. And that can kind of initiate a destabilization of the projectile at the muzzle, which will give it a little bit of a wobble on its way down the path to the target. What they call a yaw. Some different scientific terms guys use to explain that. We're going to keep it kind of colloquial for you guys. This design they found through trial and error and whatnot, when the bullet is exiting the muzzle, the gas, instead of being directed in front, hits a sharper corner in the back, and then it kind of makes a ring. Shiced. Oh boy, we're having problems. Okay, there we are. Let me back up a little bit. So what you'll have here is you're going to create kind of a ring of gas that exits around. It's going to take more of a sharp angle against the muzzle, and it's going to go off to the side so that this bullet can transition into the atmosphere more efficiently and not have to go through a giant fireball. So that's one of the reasons why these bullets are more inherently accurate, and why some of the European designs, the Skinars that the Lapuas use and stuff like that, feature this. And you'll notice like a lot of your Russian projectiles, if you pull them out of your 7.62x54s, will have a bullet design similar to this. And a lot of your match shooters like to use that. That's the reason why, one of the reasons, okay? So that's an incredible bullet design there. Let's look at this. This is kind of a hunting style bullet. This is a 175 grain spire point. And again, you can tell it's a hunting bullet because it's not designed as long range, because you got kind of a blunt front end. You don't have a bow tail. It's kind of a square butt bullet, but due to its general proportionality, it still maintains a decent ballistic coefficient in the mid 400s. I think this is 0.462. This is a 175 grain 7mm bullet. Spire point, just kind of a generic hunting bullet in that caliber. Something that's probably quite common for hunting large game like elk. And so if we move on here, you're going to see the 175 grain Alco, okay? And this is a bullet. And you can see this bullet is not the bore rider design. This is more of a conventional design. You have the standard bearing surface design. You do have the rebated tail, and you still have the aluminum tip. And this bullet is going to give you a ballistic coefficient of, I think, what would it be, like 0.764, okay? So this is a heavier bullet than the last one we looked at. This guy was 168 grains. This one's heavier, so you think that being the same general design, it would have the same ballistic coefficient, but it doesn't because of the proportionality. It's another thing with the bore rider design, the tapering of the bullet. It's a longer and sleeker proportionality because of the design. So these slight idiosyncrasies, these slight differences in bolt design can have a significant difference in ballistic coefficient. So there's a lot of little design characteristics when you're talking about the flow of a fluid across the surface of an object, And atmosphere being a fluid, right, in those respects, you got to pay attention to the details. This is a bullet that I'm going to use in my new custom rifle that you guys are going to dig. This is the Berger. Berger's got a very good reputation for kind of being the standard in long-range rifle bullets as far as like long-range precision capabilities, high ballistic coefficient, and still designed very good for hunting. This is a 195 grain Elite Hunter, okay? I'm going to use this in my 7mm-300 that I had Paul McCoy build for me. It's just supposed to be a rifle. I want something that goes out 3K. That's my plan. So we'll see how this bad boy does. But this got an incredible ballistic coefficient as well. This bad boy has a ballistic coefficient in the mid-7s. So it's got a 755 ballistic coefficient G1. I know you guys like G7 better, but we're going to keep it into G1 just for colloquial conversational purposes. So here we have a couple more Alco bullets. We got a 195s, 205, and a 208. And the BCs on those bad boys are going to be 0.8886. You're going to have 0.934 and 0.945. So these ballistic coefficients are similar to what you're going to find in a 50 BMG, which we got one over here. See? This bad boy. So it's nipping at the ankles of that, but in a much smaller, lighter, and less expensive projectile and a cartridge that's easier to reload for. So you can get the external ballistics or even superior ballistics than you would, have in a 50 BMG if you use the right bullets. So these are, again, these proprietary Alco bullets, very unique design, rebated bases on them. A couple of them are bore rider designs. As you can see, all three of these actually are here. And so you're going to have it seems like it'd be so long it'd just have a terrible pressure curve. But as you can see the shadow, this part is thicker. This is the part where it's actually 284 diameter. And you can go on their website and they have the dimensions of all this stuff and kind of an explanation of what they're trying to accomplish. So that's what's going on with the bore riders. So those are our 7mm bullets. Let's take a look at our 30 cals that I found on my reloading shelf and just kind of get an idea of what we're looking at here. So here for comparative purposes is your standard 150 grain full metal jacket. This is very similar to the 147s and the 150s you're going to find in your ball ammo in your 7.62 millimeters. This has a ballistic coefficient of 0.398, just under 400. So it's relatively okay compared to some of the other bullets we're looking at, some of your varmint style bullets in the lighter calibers in terms of ballistic coefficient. These do fly half decent out to medium ranges. It does have a boat tail. And the Metplat is relatively sharp, but it's a little, it's a little bit rounded there. So you have a halfway decent ballistic coefficient in terms of normal sporting applications and military applications. But your long-range aerodynamic efficiency is going to be inferior to your actual long-range bullet profiles, okay? So this is a good bullet for military applications. It's got good penetration, all that stuff. They're relatively cheap. And of course, it is good for Geneva Convention and all that stuff where they got laws on non-expanding bullets, whatever. So that's the primary design principle behind the military ammo here. And enhanced penetration is a thing too. Here we're going to see three different 168 grain bullets. These are all 308 caliber, 7.62 millimeter, right? And these 168s for a long time have kind of been the standard in the 30 caliber, especially in the 308 caliber Winchester target loads. A lot of your Federal premium ammo, a lot of your match ammo would shoot the 168s, a very common loading for police snipers. Even some military people have tried them. Typically they would shoot the 168 grain Sierra Matchkings, and that's been the loading for a long time. These two are very similar to the Matchking. They are a hollow point and boat tail design, so the boat tail for your aerodynamic efficiency. Your hollow point is if you keep the weight light on the front end of the bullet, it makes for better gyroscopic stability. If you have something that's slightly not concentric towards the front of the bullet, it can really destabilize that projectile during its spin and induce some wild yaw. So if they remove a lot of the weight, this is kind of hollow underneath here. It's not designed for expansion. This is more of a bullet stabilization feature. So being that the bullet was not designed to be an expanding bullet, even though it is technically a hollow point. A lot of guys have used these for military applications, and I'm not sure on the legality of all that stuff, but I think that that's fine because it wasn't designed as an expanding hunting style bullet. So both of these, you can notice some slight differences between these two. This is your Berger 168 grain boattail hollow point VLD design, and this is your Hornady boattail hollow point design. You're also going to have a Sierra that's going to be similar to this Hornady bullet. The Matchking, the venerable Matchking, which is very commonly known. The BC on this Alco, because of the rebated base and the aluminum tip design that they have employed here, is going to be 0.618 G1. That's an incredible BC for a bullet in this size. The BC on this Berger, by comparison, which is the same weight and caliber as this, is going to be 0.473, dramatically less than what we saw here. And likewise with this Hornady, I think the BC is only 0.450 on that. But you can tell by the profile of these things, you just can tell at a glance that you're going to see some radical differences in ballistic coefficient. Actually, we'll show you a little bit later the trajectory profiles of comparing these different bullets if they were hypothetically loaded at the same velocities. And the external ballistics of a 168 grain and a 308 Winchester actually match or outdo a 300 Winchester Magnum shooting the classic 190 grain Matchkings externally. So you can turn your 308 into a 300 Win Mag externally, not talking about terminal ballistics or power, but because it's a little bit lighter, but this thing really will maintain its velocity for a long time. And it makes the 308 Winchester into a formidable challenger to some of the other Magnum cartridges just by selecting a more radical proprietary bullet design. One of the nice things about the 168 grain bullets in terms of the 308 Winchester is you can get away with using a 1 in 12 twist. Some of the heavier bullets in the 308 require a little bit tighter twist than that to stabilize these. But the 168 still work good in a varmint twist. If you've got a varmint rifle with a heavy barrel configuration that you like, these things will still work. Or a hunting rifle, some of them are in 1 in 12 twists. We can look at the little bit heavier profile here. These are 175s. I believe this Alco here with the aluminum tip rebated again. And the BC on that's going to be 644. So it's a slight improvement over the 168, but even not that much more. This will work fine in your 1 in 11 twists. It'll probably even still stabilize in your 1 in 12, but I would recommend a little bit more twist on these bad boys. Maybe 1 in 10, 1 in 11, something like that would be more adequate. Here we can see this is a classic hunting style bullet. This is a 180 grain Spitzer. This is actually a Sierra bullet, and it's a flat base. And you have the lead tip, just a standard Spitzer design. Ballistic coefficient on this is 409. So again, you can see from one extreme to the other, extremely high BC aerodynamic design and a less aerodynamic design here. This is more heavily constructed internally for large game applications, something you shoot out of 30-06 or maybe 300 Magnum, something like that. I've been loading these in my 30-40 Craigs. And they fly very good. They're just because it might not be super sleek profile like some of these other long-range bullets, these have no lack of accuracy. Accuracy is not merely contingent upon the aerodynamic efficiency of a projectile. That's something else I should mention as well. Something like this, or even this other bullet I was showing you earlier, these 175 7mm bullets right here, just because they're ugly and stumpy and they don't have that aerodynamic efficiency doesn't mean they're accurate. These bullets, I was shooting 5 of them on a pinky nail. That's like less than a ½ inch at 100 yards with that Sporting Contour old school Remington 700 I got. So these things are still plenty accurate if they're tuned to your rifle and if it's a decent quality bullet. But at long range, your accuracy will be amplified by greater aerodynamic efficiency, your higher ballistic coefficients, because your wind is going to push you less, and it's going to be more forgiving in terms of trajectory and misjudging a range. So at longer ranges, these will be more accurate in terms of being able to actually hit the target because of their efficiency. But in terms of precision, they're going to group the same at 100. or potentially. Actually, these Alcos are done with very, very high attention to detail, so these will probably outshoot a lot of your other bullets just because of the quality control on them. He pays very close attention. These were kind of designed for match applications. But just wanted to mention that as well, that just because this might not be as sleek as the other ones doesn't mean it's not accurate. It's just not specifically designed for long range accuracy considering wind drift and all your other variables, okay? Here we have kind of a classic. This is your 190 grain bullet. This is your 190 grain Sierra Matchking. This is a very common loading here in your 300 Winchester Magnums. A lot of your 300 belted Magnums will shoot this bullet. This has kind of been the standard long range precision choice for a lot of your snipers that do employ the 300 Winchester Magnum. That is a round that is used by the United States Army and the Navy in the M24 rifle system and in a few other rifle systems that they use. This is something that is actually fielded by the military. And the 190s have long been a very good bullet. Ballistic coefficient though, on the standard Sierra Matchking design bullet like this with the contour, just because of the proportions in a 30 caliber. 30 calibers generally are going to have a little bit less ballistic coefficient in the same weight ranges that are more popular than say a 7mm will. It's still, when you compare it to the 7mm projectiles, which are longer and sleek in a similar weight profile, the 30 caliber is going to be proportionally stubbier and shorter typically. So this has a BC of 0.533. which is actually less than the BC on this 168. And that's how come this 168, in terms of your trajectory and ballistic efficiency, will maybe keep up and even outperform a 300 Magnum shooting this classic, this classic 190 grain bullet. So that's something to keep in mind. There's a lot of differences between bullets coming out now. There's some stuff you probably want to take a good solid look at. Here we have, I believe this is the 200 grain rebated steel tip. And this is actually using a steel tip projectile. And he originally was doing these in steel tips, but then he also did come out with a new aluminum line that's actually working out better. And for some legality purposes, just for making it less sketchy on the lines there, I think they did kind of gravitate towards the aluminum tips. Don't quote me on that, but I suspect that's one of the reasons they did kind of get away from the steel tips. Some folks were worried that this might eventually be classified as an enhanced penetration or armor piercing type bullet design if someone was ever going to load this in a pistol round, like maybe a 300 Blackout or something. There could be legality issues with doing that. So these are designed for use in a rifle. This is totally kosher still, by my current understanding. This here is an example of a Nosler. This is an Accubond bullet. And Nosler Accubonds have a good reputation for holding their weight. So if you're looking for a long-range hunting bullet, something like this is actually going to give you pretty good performance. These Accubonds, if I'm not mistaken, this is a 190 grain Accubond, so this would be for large game, or if you're shooting at very long range, you could use this for deer. This would be about right for that because you're going to lose a lot of your speed, you're going to want to have more weight. So 190 grain Accubond, ballistic coefficient is 588, which is actually very good in a 30 caliber. So for long range hunting, something like this, there's a lot of other premium hunting bullets out there that a guy can look at that are going to give you very similar long range performance. One of the nice features of these Nosler hunting bullets is that they still expand at low velocities, which would be your longer ranges. And if you do make a shot at closer ranges at high velocities, it won't overexpand. So it's a controlled expansion projectile. And that's all internal in the design, something that you can't see from looking at the outside. But for hunting applications, this is a good way to go. And here we can see a couple of 338 caliber bullets, some of the heavier profile designs. This is a 285 grain Hornady boattail hollow point, and this is a Sierra 300 grain Matchking. Now you can see that the profile externally looks very similar, very difficult to tell the difference between the two. The tip is slightly different, the angles, the profile is a little bit different, and the boattail on this is a little more tapered, but a lot of this weight difference, or 15 grains difference, this is lighter than this one, it's going to be internal. This nose portion is going to be empty on these hollow point bullet designs, and this one is just simply a little more empty than this one, And so that's where you get most of your weight difference from between the two. Now you will notice a difference in ballistic coefficient that is significant, even though the external profile is very similar. When you look at the two, this is going to have a ballistic coefficient in the mid 700s, like 760 something, okay? I forget exactly what it is. This one is right in the lower 700s, about 700 on the BC. So the weight increase, even though the external dimensions are very similar, that extra 15 grains is going to give you quite a better ballistic coefficient when you're talking about aerodynamic efficiency. More momentum makes it more difficult to decelerate due to the atmosphere or to deflect due to the atmosphere, just because you got momentum, right? Now if we take a look over here, this is a 35 caliber bullet, a 358 caliber. This is used in a 35 Wayland that we got laying around, and that thing is a 225 grainer. And just so you can get an idea as to the ballistic profile here, it's shorter and stubbier, so you're only looking at a 0.370 ballistic coefficient on this, just from proportionality. And here we have the 50 caliber rounds, a couple different examples. I don't got all of them laying out on the table, but here's, I believe this is an M8 API, armor piercing incendiary round. This is not designed for long range target shooting, just from its raw weight and because of the longer profile on it. But it still has a decent ballistic coefficient in the 600s or 700s. I forget exactly what it is offhand. This is one made by Barnes. This is solid alloy. This is kind of a bronze or a copper alloy, okay? And this is actually a bullet that has a pretty decent BC on the order of over 1,000. So because of the long profile, the shape, the sharp point, and the weight, this thing is kind of going to always be the master of your ballistic coefficients. But you can compare this 50 caliber bullet, which is a few dollars a shot. If you have a high efficiency 7mm bullet, like a proprietary bullet like one of these Alcos, you're going to have a BC in the 800s and 900s. So your 7mm bullets are going to have the same aerodynamic efficiency, very similar to that of a premium extreme long range precision 50 caliber projectile. So you don't necessarily need to have this much gun to hit targets at the same distances and maintain your velocity and cut through the wind as well as these. These 7mm will have a similar wind drift to something like this. Actually, if you have a loading that's higher velocity, a lot of times you can get the stout 7mm cartridges, your 28 Nosler, maybe your 7mm Shooting Times Westerner. You might be able to get these going faster than the BMG would, in which case you're going to have a dramatically improved ballistic performance, externally speaking, even sometimes superior to the 50 cal.